Work zones are some of the most unpredictable and high-risk areas on our roads, where 4,000 crashes and 22 deaths occurred last year in Ohio. Road construction workers represent a large pool of our workforce that put their lives on the line every day to maintain this critical part of our infrastructure, with over 5,500 workers in-state and over 140,000 nationally. As we move to smarter and more connected transportation systems, it's important to use this technology to improve their safety, not just for the workers themselves, but also for the drivers sharing the road. Hello, I'm Dr. Timothy Seitz. I'm a research scientist here at the Transportation Research Center and the principal investigator for the SmartBarrel technology. The SmartBarrel technology allows us to have a centimeter level localization of the work zone boundary and then communicate that with the drivers upcoming on the roadway so that they can have advanced notification and respond to the work zone in a safer way.
In 2024, the Ohio Bureau of Workers' Compensation, through their Workforce Safety Innovation Center, awarded the Transportation Research Center a grant for the SmartBarrel program. The Workforce Safety Innovation Grants are focused towards innovative ideas to help improve safety through personal protective equipment or personal protective technologies. Our process will begin with the design and development of the prototypes, followed by assembly of the prototype components to the barrels, then move to the controlled environment testing at our proving grounds. Then finish with the public road deployment to gather data in a real-life scenario on public highway construction zones. Through this process, the Transportation Research Center has worked with several partners. Michael Baker International conducted the stakeholder engagement activities with some of our neighboring DOTs and road construction contractors. Valtech Mobility engineered and designed a complementary barrel, as well as a communication technology and coding that can work with our TRC barrels. And the Ohio Turnpike assisted with letting us use a 3-mile stretch of their turnpike in a live construction zone for public deployment.
Because this technology is still new, there's still a lot of foundational work that needs to be done to enable it. So right now, we don't have work zones that are equipped with this kind of information collection to know where the edge of the work zone is. So our technology really is going to be able to push this technology forward and enable it in a new way, because previously there was no way to collect this information without a lot of burden on construction zone workers. So there's messages that we can send out called the Traveler Information Message. This allows the work zone geometry to be sent to the workers and what time the work zone's active and whether workers are present. This can be ingested and even integrated with maps inside the vehicle in the future.
In this demonstration, we're going to help you visualize what barrel accuracy could look like on road maps. Note when the operator drops a barrel. It sends its GPS coordinates to the work zone hub that would then push that information out to the cloud. For instance, those coordinates could then be used by map providers or third-party apps to show barrel placement. Accuracy is key here, especially down to the centimeter level. This can be highly beneficial, especially in scenarios where daily lane closures or lane changes are part of highway construction plans.
So one of the key enabling technologies of the SmartBarrel is C-V2X, which stands for Cellular Vehicle to Everything. This allows for messages to be sent directly to vehicles and therefore the drivers in the vehicles. By having an accurate geometry of the work zone ahead, we're able to communicate that directly to the drivers in their vehicles using this technology.
Each SmartBarrel is equipped with an IMU. This IMU detects movement, impact, or shock events and instantly awakes the system. The system is powered by a compact battery and a 1-watt solar panel, all contained neatly within a barrel enclosure, adding minimal weight to the barrel's weight.
I was tasked to mount these devices inside the barrels. To do on the inside of the barrel because if it comes in contact with the vehicle, we want to make sure the unit themselves does not become a projectile. And that was another good reason why we decided to mount them inside of the barrel. It gives them a little bit more protection from the weather. One of the other interesting factors that we had to take into account and consideration was the durability of the units and the barrels themselves. So we would set up on our test track hitting these barrels at 35 miles an hour and at 60 miles an hour. And yes, they did survive.
Each of these steps that we took with stakeholders really showed the excitement that there is for this project, and their investment to help make sure that it hits all of their needs really came through. And I think as we take next steps to further develop this product and really seek commercialization, we can make it to where it is lower cost and more deployable, and will really be used to reshape the construction zones nationwide to make them safer both for the drivers and for the workers that are there.